Hello guys, so today our topic is beta oxidation of fatty acids. So fatty acid is nothing but a carbon skeletal with a carboxylic acid, and naming is done just consecutive to the carboxylic acid is known as alpha carbon, then beta carbon, then gamma carbon, and then delta carbon. The other way is named according to the last methyl group. Last methyl carbon is known as omega 1, then omega 2, then omega 3, and omega 4 carbon. In beta oxidation, we see cleavage between alpha and beta carbon of this carboxylic chain. The most common oxidative pathway of fatty acid is known as beta oxidation, and it occurs in mitochondria of liver, adipose tissue, and many other organs. The least common oxidative pathways are alpha oxidation. It is seen in endoplasmic reticulum and peroxisomes. Omega oxidation, seen commonly in endoplasmic reticulum and microsomes. Odd chain fatty acid oxidation in mitochondria. Unsaturated fatty acid oxidation in mitochondria. Very long chain fatty acid oxidation in peroxisomes and mitochondria. Now we are seeing beta oxidation of fatty acids. It is done in 3 steps. First, fatty acid is activated in cytosol of the cell, and then it is transported across the inner mitochondrial membrane of the mitochondria, and then the rest steps occur in mitochondria. So the first is activation. Activation of fatty acids is occur when they are converted into acyl coenzyme A. Acyl coenzyme A is the activated form of fatty acids. It includes two-step fatty acid. It converted into acyl adenylate by using ATP and releasing inorganic pyrophosphate in the presence of enzyme thiokinase. Then acyl adenylate is further converted into active form of fatty acid known as acyl coenzyme A by using CoAs enzyme and releasing AMP in the presence of enzyme known as acyl coenzyme synthetase. Now we are seeing transport of activated form of fatty acid, that is acyl coenzyme A, across the inner mitochondrial membrane. Acyl coenzyme A alone cannot be transported across the inner mitochondrial membrane. Hence, it combines with carnitine molecule in the presence of enzyme CAD1, also known as carnitine acetyl transferase 1, to form acyl carnitine molecule, and then acyl carnitine molecule requires a carrier protein known as translocase in inner mitochondrial membrane to transport across the inner mitochondrial membrane and come in matrix. And in matrix, CAD2 enzyme is present that converts this acyl carnitine into acyl coenzyme A and carnitine, again the start molecule. Now the last process is steps. The steps that occur in the mitochondria matrix. There are 4 steps that occur in mitochondrial matrix. First is oxidation in the presence of enzyme acyl coenzyme A dehydrogenase, then hydration in presence of enzyme enoyl coenzyme A hydratase, then further oxidation in the presence of enzyme beta hydroxyacyl coenzyme A dehydrogenase, and then cleavage of the product into acyl coenzyme A and acetyl coenzyme A in the presence of enzyme thiolase. Acyl coenzyme A and acetyl coenzyme A are the final products of beta oxidation. Now we are seeing steps. First, acyl coenzyme A. Steps are occurring mitochondrial matrix. Acyl coenzyme A is converted into trans-enoyl coenzyme A. It is oxidized, hence FADH is reduced into FADH2 in the presence of acyl coenzyme A dehydrogenase, and FADH2 will further be converted into 1.5 ATP during electron transport chain. Then trans-enoyl coenzyme A is hydrated into, in the presence of water, hydrated into beta hydroxyacyl coenzyme A in the presence of enzyme enoyl coenzyme A hydratase. Now the third step is again oxidation. Now beta hydroxyacyl coenzyme is again oxidized into ketoacyl coenzyme in an simultaneous reduction of NAD plus occurs to form NADH2, and NADH2 will further form 2.5 ATP during electron transport chain, and all this process occur in the presence of beta hydroxyacyl coenzyme dehydrogenase. Now the last process, that is cleavage of ketoacyl coenzyme, occurs in acyl coenzyme and acetyl coenzyme and in the presence of enzyme thiolase. Now these are the final product of beta oxidation of fatty acid. Now this acetyl coenzyme will be utilized during TCA cycle, and acyl coenzyme will again undergo beta oxidation of fatty acid. Thank you.